Hi folks, today's topic is graphing piecewise functions. So a piecewise function is a function that's made up of a bunch of pieces. So we have this overall equation and it's got three different pieces that we will graph depending on where it is in the domain. So our learning target is to be able to sketch a function based on its equation or come up with the equation based on its graph. And then we know we'll be successful if at the end of the day we can do those two things. If you can look at an equation, a piecewise function, and then make it sketch, or if you can go in reverse from the graph and make its equation. All right, so let's just look at this one that's already drawn for us and kind of talk about what a piecewise function does. So this function is broken into three sections. Each section lives on a different part of the domain. Now notice, our domain usually goes from negative infinity to infinity. And if we look, this first function lives for all the x's that are less than or equal to -3. Then this next function starts at -3, not included. So this starts at -3, but it's not really at -3. It's the very next thing. And then it goes until 2, including 2. So right now we've got all the numbers before -3 up to -3. And then our next piece starts at -3, not including it, and then goes until 2, including it. And then our last piece goes from 2 and on. So we've got all of the x values from -infinity to infinity covered. Any number that you could think of will fit into one of these three pieces of the domain. So this graph, linear, right? Just x, there's no squared or cubed or root or anything weird. So this is going to be a linear function. This is the graph of -1/2 x plus 2 that gets chopped off. It only works for all the x's that are less than or equal to -3. Any x that's bigger than -3 gets chopped off. And if you look at this function here, that's what's happening. So I like to kind of highlight the boundaries. So this line ends at -3, and look at the next segment, the next piece begins at -3. Now, because this one is included, it's less than or equal to, we have a closed circle, which means it's included. And then this one, it's open circle because that -3 is not included. Our next boundary line occurs when x is 2. The middle function lives for x equals 2, so it's included there. And then this function does not include at 2, so the other graph was an open circle for that end. And let's look at this first function to kind of, or this first linear graph to kind of get an idea of what's happening. I'm going to graph -1/2 x plus 2 and see what it looks like. So this is slope-intercept form, so that's the slope, that's the y-intercept. So I'm going to start at plus 2. My slope is -1/2, so I can put the negative with the 1 or the 2, not both. I'll put it with the top. So that takes me down 1 over 2, down 1 over 2. And then I ran out of room, so the reverse of down 1, forward 2 is up 1, back 2, up 1, back 2, up 1, back 2. And you look at what happens here. This is the line y equals -1/2 x plus 2. But because we restricted the domain, that line gets chopped off for any of the x's that are not less than or equal to -3. So everywhere that x is less than, all the x's that are less than or equal to -3, that graph survives. Everything that's all over here, this part of the line, gets excluded, gets chopped off, because those have x values that are greater than -3. I want to point out one more thing, and then the same idea for the next. I don't want to graph this, but you could probably trust that this is the picture. So that line starts at 11/5, which is 2 point whatever, and it goes up by 7 over by 5, whatever. That line only lived between -3 and 2. The real line goes, for infinity. But this gets chopped off because of the domain. Now I want to point out one more thing, that if you get chopped off and you're in between, we call these lattice points. This is called a lattice point. It's a lattice point because it's one of the nice it's an intersection of integers, basically, is a way to think about this. This is the point, 4 or 6 or 7, something like that. That's a lattice point. This is not a lattice point. That's not a lattice point because it has decimal x or y values. So if your graph chops off at not a lattice point, that's okay. You got to chop it off wherever the x value fits with the restriction on the domain. So this graph, look at this is a lattice point, this is a lattice point, the next lattice point is there. So wherever your graph is, when it hits that domain, that boundary line, you've got to chop it off right in between. So I'm going to say chop off graph even if you're not at a lattice point. Okay, so it's okay to chop off your graph even if you're not at a lattice point. Wherever the graph, the domain changes, boom, you stop it there. All right, so if I'm going to sketch this function, I've got this graph, and then we've got them chopped off over these domains. So I like to start with something that I can erase. So start off with, actually, I'll just use X's. How about we go with a light color, and I'll just X out the ones that don't belong. Let's do like a light pink here. So this graph starts at -5, so 1, 2, 3, 4, -5. And then the slope is -1/2, right? Make that into a fraction. I would go down 2, I ran out of room. So as I try to go down 2/1, I ran out of room, so I'm going to do the reverse of that and go up 2, back 1, 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 up 2, and then I ran out of room that way. Now, I don't want to draw my line yet because I've got a restriction on the domain. This graph only lives for x's that are less than -1. So now I'm going to get a darker color, let's say purple. I'm going to go through and I'm going to say which one of these points fit with this x is less than -1. Well, -2 is less than -1, -3. This has an x value of -4. This has an x value of -5. And so you kind of want to just connect it and you're done. No, you've got to connect all the points, even the decimal ones that aren't on lattice points. So like this point and this point and this point, there's infinitely many points. So we've got to bump right up to where x is -1, but we can't include where x is -1. So what do we use instead? Obviously, you've probably already thought of it. Open circle. Connect the dots on that. And now this graph lives for all the x's that are less than -1. Sometimes it's nice to put a little x on those other points to exclude them so you don't get confused. All right, let's graph the other one. My y-intercept is 2, 1, 2. My slope is 1/1, so rise 1, run 1. Okay, now that's the full line. We want to restrict it for only the x's that are greater than -1. So I go to x is -1. This time I want to include that. I want to include that one. And I want to include all the ones that have x's, all the points that have x's that are greater than -1. All these other ones, I'm going to put little x's on them. I don't want them to be included. Now, eventually, when you get good at this, you won't have to draw the whole thing. You'll just, like the next one I'm going to draw, I'm not going to draw the whole thing. I'm going to chop it off at the boundary line. Okay, there's my function. Now, it's real nice to have highlights on these 2 points, especially to indicate that you are including this one and excluding that one. All right, let's try this one without doing, I'm going to go through without doing the whole line. Let's chop it off. So what I'm going to do is I'm going to draw the boundary line right now. So my boundary line occurs at x equals 2. Okay, so my first graph starts at -5, 1, 2, 3. Now this is for all the x's that are less than 2. So that's everything on this side. So -5, 1, 2, 3, 4, -5. I'm going to include that point because that's on the less than side of 2. Then I'm going to rise 2, run 1. That's included. Rise 2, run 1. Oh, I'm on the boundary, so I got to check. Do I want to include or not include? And this one I do want to include. I have enough points to draw myself a decent line. There we go. Okay, now let's try the other one. This graph starts at, this piece starts at +3. 1, 2, 3. Now I don't want to mark that because this graph only lives for x's that are greater than 2. So I'm only going to graph the ones once I start to hit the boundary at 2. So 1, 2, 3, and then my slope is -1/2. So 1, 2, 3, down 1 over 2. Okay, I'm on the boundary. Do I want to include or not include? Not include because it's just greater than 2. Then down 1 over 2, down 1 over 2. I've got enough info there to play connect the dots. There's my piecewise function. I don't mind if you do the other ones as long as you cross out the points that don't belong. Okay, if you like to draw the whole thing and then chop it off at the end, that's fine. If you can get to this spot where you draw the boundary line, that looks a lot nicer, as you can tell, between the two. But in a perfect world, you don't draw the boundary line at all. Anyway. Okay, so here's 3 pieces. I'm going to encourage you to pause at this spot and try to do this one on your own. Alrighty, let's see how you did. Okay, so I have 2 boundary lines. I'm going to draw them both this time. I have a boundary line at -2. I have a boundary line at 1. Oh boy, that middle piece is going to be not much to draw. Okay, so here we go. So this lives for everything less than -2. So I'm not going to start drawing anything until I get past on the left of -2. So it's going to start at -2. Slope is down 1 over 2. So -2, down 1, forward 2. I don't want to do that because it's going the wrong way. This only lives for x's that are less than -2. So I'm going to start at -2. I'm going to go up 1, back 2, include, up 1, back 2, up 1, back 2. I've got enough info. There we go. I'll go and I'll highlight all. I'm going to draw all 3 of them at once when I get my straight edge. This one starts at 4. It's in the middle between -2 and 1, and that's where the y-axis is, so I can actually draw the point at 4. Up 1 over 1. Okay, that's not included. I ran out of room because if I keep going, I'm not going to be in my domain, my restricted domain. So I'm going to go instead down 1, back 1. Down 1, back 1, and that one's also not included. And then finally, we start at +4, and our slope is -1 over 2. 1, 2, 3, 4. I'm not going to mark it because it's not my domain. Down 2 over 1, included. Down 2 over 1, included. Down 2 over 1, down 2 over 1, down 2 over 1. So, I can grab my straight edge now. Play connect the dots. And I have this beautiful piecewise function. For now, I'm going to have you only do linears. Excuse me, going forward, once we get into more of transforming functions, I might have you do a function that is more interesting than just a line, but most of them will be linear. All right, this is the other way. Now I'm giving you the picture, and you need to come up with a function that represents that picture. Pretty straightforward. We just look and see. These are line segments, so they're linear. So this has got to have a y-intercept and a slope. So I'm going to start off with the y-intercept. I'm going to go find another nice lattice point. All you need is two nice points to figure out the equation for a line. So my slope is up 2 over 1. So that's 2x. My y-intercept is +1, comma. You could put a comma or just a space. Usually a comma is nice unless you can really space it out like the computer does for me. But I prefer to write a comma when I'm doing it on my own. Now this lives for all the x's. Draw my boundary line again. This lives for all the x's. All of these points have x values that are smaller than 2. Now, do I want to include or not include? Because that's filled in, I want to include. X is less than or equal to 2. All right, now this one, I've got my lattice points. So I could find a nice lattice point there, a nice lattice point there. So that's going to help me figure out my slope. Remember, you always do slope left to right. Even if it kind of makes sense to go the other way, don't do it. Always look at it left to right. So I'm going to go down 1, forward 2. So my slope is -1/2 x. And now the y-intercept. Remember, the y-intercept isn't just where the y is when it stops, it's where it hits the y-axis. So sometimes you have to work your way back, up 1, back 2, up 1, back 2, up 1, back 2, until you hit the y-axis. So this hits the y-axis at -1. And then which x's are included? We don't want to include 2, but we want to include everything bigger than that. So x is greater than 2. Again, I'm going to encourage you to pause and try to do this next one on your own now that you've got the idea. All right, let's see how you did. What do I want to go with here? I just used a purple, a yellow, a pink. How about a bright pink? Okay, so I've got some boundary lines. Let's draw those boundary lines first. This is where my graph transitions from one piece to the next piece. I've got to find some lattice points. There's a nice lattice point. There's a nice lattice point. So this first section goes down 1, 2, 3, forward 2, so -3/2. X, and now I got to figure out the y-intercept. So down 3 over 2, down 3 over 2. So that's going to hit right there, 1, 2, 3, -4. And that lives for all x's that are just less than -2. I don't want to include that point. Next segment, I love these. Horizontal lines are the easiest because they just have one y value forever. This y value is -4. The slope is 0, so it would be 0x. We don't need to write that. Now, this goes between -2 and 3, and this is how mathematicians say between. They start at the low number, -2. We want to include it, because it's a closed circle, until we get to 3, and we don't want to include 3. So -2 is less than x is less than 3. This is how mathematicians say, like, all the numbers between -2 and 3. All right, the last segment I want to highlight. There's my lattice points. I got to work my way backwards. Remember, you always want to go left to right. So I'm going to work backwards to find the y-intercept, but when I do my slope, I go left to right. So this is down 2, forward 3. So that's -2/3 x. And then now I'm going to work my way backwards, up 2, back 3, up 2, back 3. And it looks like it hits at +4. Now that lives for all x's that are 1, 2 that are bigger than or equal to 3. All right, there you go. Give the homework a try.